Okay, guys, let's wrap up this project today. So it's going to be a little bit of a letdown here. It's the world's slowest robot. So when I started this project, I didn't realize that these motors here have a 64 to 1 reduction in them. So it's hard to drive them fast because the gear reduction. They have a ton of torque though, but yeah, they don't move very fast. So we've created here the world's slowest robot. Another problem that I totally foresaw happening, but didn't come up with a good solution yet. The wheels don't grip on anything that's not rubber. So for temporary solution, just using these little hair scrunchies when I got it on the floor or something, and that works. Rubber band would work better. I just don't have any that are the right size. Um, I knew that was going to be a problem though. 3D printing, of course it's, unless you use like TPU or something to print with, your tires aren't going to be very good. So yeah, let's get into this. This should be the last part of this series though, which was building a robot with my son. He really, so had this, GM PCM right here that I let him take apart, and he was like, hey, I want to build a robot out of it because, it does kind of look like a robot. It's got a little robot face going on to it. So I see what he saw. So we built a robot. So that's what we got here. It's got a Arduino, and then it's got two stepper drivers, a little breadboard here. So that way, if I wanted to add some stuff in the future, it's there. And then these 28 BYJ-48 stepper motor. So that's all there is to it. It's all 3D printed out of PETG, and that's really all there is to making it. Wiring it up is pretty simple. I know I said I was going to go over wiring. I was planning on making a diagram to explain it, but it's so simple, no need for the diagram. I know it's easier to follow a diagram, but here, let's just go over it. So you got int 1 through, or in 1 through 4 on the connector here. So we got in 1 through 4, and then we just put them at 4 of the pins together. And then same deal here for the stepper motor there. It's got in 1 through 4, and I just went 2, 3, 4, 5 for it. And then for the other motor, it is 6, 7, 8, 9. Now, it doesn't have to be in that particular order. You don't have to do that. You can put them in whatever order you want. You just make sure you set it correctly in the Arduino IDE. And then for powering the motors, you just have the 5-volt out from the Arduino board and goes to my little breadboard. I got a capacitor on there. The capacitor was because my battery doesn't supply enough voltage all the time, and it would sometimes randomly shut off on me, so that would prevent the voltage spikes that shut it off. But that's completely because of this battery bank. If I just have it plugged into one of the little USB chargers the whole time, it doesn't give me any problems. So yeah, that really goes over the wiring of it, because these just connect to the board. They have a connector that connects there. So that's that. And then it's just got the USB-B connector to USB-A on there. So that's the setup. All right, so let's take a look at it in Arduino, because there are some traps for, new players here that need to go over before you go wild on this. So yeah, let's take a look at that, and then we can get back. Okay, so this is the current sketch that's on it, just to give you an idea of how it works, and we'll go over that trap that I was talking about, and I will show you the trap in action with a different sketch here in just a moment. So I'm using the ACCEL stepper library, which is a stepper library that lets you slowly ramp up or ramp down your stepper motors, and it also has built in for it if you want to run 2 simultaneous stepper motors at the same time in the library, so I don't have to write that myself, which stepper.h, the more common library that most people use with Arduino. That one does not support it in the library. It's pretty easy to make a case to do it yourself, but I'm not going to go into detail about doing that, but I will just show you what I'm talking about. So let's just create a new sketch. So File, New, and we want to use, we're going to include stepper. So this goes before the void here. Be include stepper.h. Okay, next you need a constant variable of how many steps it takes. So it's a int, and then we'll just name it steps. I'm gonna use a z because I'm not sure if steps itself is used, and that should, if I remember right, it's 2,000 steps is one revolution of the stepper motor on here. Okay, so that should be per rev, just that way we don't forget. Oh, I forgot to. There we go. And then the next one is just part of the library. Okay, so next one is stepper. And then I think it goes the name of the stepper motor. So motor 1. That's right. Okay, so it goes motor 1, and then steps, so that way it knows how many steps is a full revolution, and then the pin order. So we'll go with motor 1 is going to be, all right, so 9, 8, 7, and 6. 9, 8, 7, and 6. And we'll just copy this and make it motor 2. Motor 2, which is, starts at, what would that be? Yeah, 5, 4, 3, and 2. Okay. All right, so now we have both our stepper motors defined using this library. Next, we just need to actually tell it to move. All right, so in the setup, you need to define the speed for the motors. So motor 1 dot, all right, set speed. And motor 2. And 60 is way too fast for this stepper motor. Let's go ahead and give her the old 14 there. It should work. Okay, so now we just need to tell it to rotate 1 time. So motor 1 dot step, and we need to do steps. And end that. We'll just copy it and paste it again. Motor 2 steps, and then just give it a delay. Wait a whole second, and then just do it again. All right, and then it'll just continue to try to do it. So if you understand how an Arduino works, you're already going to know what's going to happen here. What it's going to do is it's going to step motor 1, and after it's done, it's going to step motor 2. So it's going to go that full rotation and then try to do the next full rotation. I can't remember what the max speed I was able to get out of the motors. I know it was like 14 revolutions per minute. I forget how this library works, so we'll see. That's either going to be incredibly slow or that's the max speed I can get out of these motors. So yeah, that's how this library works. This is the other library. Pretty similar setup on it. You know, you define your motor here, define what a full step is, and you go through the list there. So yeah, let's try to run this. Okay, so I just tried to run it. Just gave it a quick test run. I was like, hey, these motors are not moving right. I forgot the grouping of the wires, although I did it like that. In the software, it should be this. So 7, 8. So yeah, 9, 7, 8, 6. Because it's 1, 2, and yeah. It's just how it's done. Okay. So 5, 3, 4, 2. Okay. And we should be able to get it to run at 12. All right, let's plug that back in to the computer. Okay, so as you can see, with it wired up like this, with this particular setup, it runs one wheel and then the next. And since we programmed them to run in the same direction with the wires hooked up the same way, instead of reversing one of the motors, it's going to try to drive straight with one and backwards with the other and just make it go in a circle with that particular setup. So those are kind of your two little traps you got to pay attention to. And you can easily still use this stepper motor library and just write a case where basically maybe move 2 steps here and then move 2 steps there and just go back and forth on the 2 until it completes that revolution that you tell it to move as many steps as you've told it to move. So it's really not that hard to overcome that in this library, but I'm lazy. I didn't want to write any code because as I was playing with it in this library at first and was like, oh wow, this is incredibly slow. So yeah, that's the problem you run into with this particular stepper motor. Is it's just an incredibly slow stepper motor, but it has a ton of torque, so you can use it for other things. I just wouldn't use it for propelling a robot. So pretty simple setup, pretty simple sketch. And we'll take a look at the other sketch now. Well, we looked at it at the beginning. You saw how it worked. Okay, well, hopefully my pecking away at the keyboard really slowly didn't drive y'all too crazy, but I still haven't got a keyboard mount yet for this new workbench, so it was sitting in my lap. So, yep, I pecked away really slow at it. Hopefully you guys enjoyed the video. I really just wanted to wrap up the loose end on this project since I showed the design, showed the build, and built it, and then never finished it. So I wanted to tie up that loose end. I just kind of felt bad leaving it in the air like that. Like I said, my son really enjoyed it. I was disappointed in it. I thought it was kind of slow, but he really liked it. He thought it was pretty cool. So if you have the stuff laying around, maybe worth doing. Again, you can build the robot into anything. If you're interested in the files from building this, like the 3D printed files and stuff, I'm happy to post them online if there's any interest in them. I just kind of feel like there's no interest in it because it's going to be so slow. But if there is interest, I can post those online, and it is turn anything into a robot 3D printed. So, you could just turn a board into a robot with that. It's nice and flat, so that way, you just do anything with it. But yeah, project's done, so probably not going to do any more content on the robot unless I have some change of heart there. I'll probably build another robot in the future with my son, but who knows when that'll be. Or maybe I'll build one with one of my daughters. So maybe my next video coming up here soon will be updating the software on this guy. I'm sure y'all have seen this before on the channel. It is the KSGER T12 soldering station. It's one of those cheapo soldering stations that work with the Hacko tips. They're great for beginners. It's not my daily driver. I got it basically so that way I could review it for myself and make sure it was worth suggesting to people before I did. I don't like to recommend something I haven't used before. There's plenty of other channels out there that do that. They'll have a bunch of recommended products and they've used 1 or 2 of them, and I don't like that. So I wanted to buy one, test it, and use it before I recommended it. It is a good station. I have another video on modifying it to be ESD safe. Got a tiny bit of criticism on that video. Basically, people were unhappy with the fact that I did not use like a 1 mega ohm resistor on there, but I don't know. a path straight to ground is safer than no path to ground. So yeah, come on. So don't beat me up over it, but yeah, I had to do the modification because I was noticing this thing would light up LEDs. So I had to give it a path to ground to stop that. So yep, I gave it a path to ground and that solved that problem. Now, some people have released some open source software for these things, and you can modify it to work with the JBC tips instead. You obviously have to get another JBC pin to wire into it, but yes, it will work with JBC pin or tips now with that modified software. So yeah, that's what I want to do is I want to put that software on there. And maybe I'll get rid of my Hacko pin and my Hacko tips and just run JBC stuff. I doubt that'll happen though. But yeah, it's definitely a future video. Not sure if it's near future or far future. I do have other projects too for you guys. I need to do another IPC hammer video. I need to do, I have a couple, I need to do the 400 mile an hour speedometer video. So yeah, I have some videos that are in my to-do list and I will try to knock them out sooner than later. But I hope you guys enjoyed the video and I will see you in the next one.